Hello everyone, and then welcome to another video. Okay, so in this video we'll be solving what questions on impedances, okay, capacitance, inductance, impedance, and all that. Okay, right. So in case this video becomes very useful to you, I would urge you to subscribe to the channel, hit on the bell icon so that you don't miss out on any uploaded video. Like the video and then let me know your questions in the comment section. I will reply to them as soon as possible. Okay, right. So let's take our first question. Okay, right. So we have what a series RLC. Okay, so it means that we have a resistor, inductance, and what capacitance. Okay, so we have a series RLC. Okay, circuit having a resistance of what 50 ohm, inductance of 500 millihenry, and then capacitance of what 400 microfarad. Okay, and it's energized from 50 hertz to 30 voltage. Okay, or volts AC supply. Okay, we have to find the resonant frequency of the circuit, peak current drawn by the circuit at what the 50 hertz. Okay, and then we have what the peak current drawn by the circuit at resonant frequency. Okay, so at this frequency. Okay, now let's see how we solve that. Okay, right. So for resonant frequency, okay, from my previous video on what impedance and inductance, capacitance, and all that, we got to know that resonant frequency, okay, is equal to 1 over what 2 pi. Okay, we have the root of LC. That's what the capacitance and what inductance. Okay, right. So let's see what we have. Okay, so from here we have what we have 2 pi. Okay, and then we take the root of what the inductance, which is what 500. Okay, milli. Okay, so we have what 500 times 10 exponent minus 3. Okay, and then you multiply that by what your capacitance. Okay, so you have capacitance of what 400. Okay, 400. So this is what 10 exponent what minus 6. Okay, 10 exponent minus 6. Okay, so we have our what resonant frequency. Okay, so when you compute all of this, you might end up with what 11.25 hertz. Okay, that will be our resonant frequency. Okay, that will be our A. Okay, resonance frequency. Now let's move on to what B. So you can notice that A is quite straightforward. Let's look at what B, the peak current drawn by what the current at 50 hertz. So now the peak current, okay, this is our peak current. This is how we represent our peak current. Okay, we know that that's what V on what the impedance. Okay, and then we already know this formula. Okay, we already know this formula. All we have to do is just find our impedance. Okay, and then we already know our Vm. Okay, we've been given Vm. Okay, right. So let's proceed from there. Right. So we have so first we need to calculate what Vm and what Z, so that we can substitute that into what Im to find what our peak current. Okay, now you know that our resistance is what 50 ohm. Okay, from here we know that our resistance is what 50 ohm from here. Right, so let's proceed. And then we know that what XL, okay, from impedance calculation we know that XL is equal to what 2 pi f what L. Okay, so we have what 2 pi what frequency of 50 and then times what 500. Okay, 500 times 10 exponent what minus 10. That's our what inductance. Okay, right. So from here we calculated the frequency using the inductance. We are using the same over here. Okay, so when you calculate value for XL, we have what XL to what 157 ohms. Okay, now let's calculate SE. Okay, for SE, okay, for SE we have what 1 over what 2 pi FC. Okay, so from there we can calculate that from here okay, we have what 1 over what 2 pi times our frequency, okay, times our what this value, okay, right? So we have what 400 times 10 exponent what minus 6, okay, right? So when you calculate that, calculate SC, you end up with what 7.9 ohms, okay. So when you punch that on your calculator, you end up with what 7.9 ohm. Now this is quite straightforward. You know that SC, okay, when you subtract SC from XL, okay, we'll end up with what X, okay. And then this formula, okay, comes from our initial what tutorial video on what impedance. That's why I initially stated that you need to take those formulas very serious. They are very important, okay, very important. Without them you cannot do simple calculations, okay, right? So we know that XL is what 157, and then we know that SC is what 7.9. so when you compute this, you end up with what, when you subtract this, you end up with 149.1 ohm, okay. So from here you can then compute impedance, okay, Z, okay. Now so you know that what impedance Z, okay, is equal to what R squared, okay, plus X squared. So from here you can just compute impedance as what R squared, okay, plus S squared. So we have impedance of R, okay, you know R to be what 50, okay. From our initial stage, you know that our resistance, okay, is 50. So we have what 50 squared and plus what X value, that's what 149, okay. So we have 149.1 squared. So we now have our impedance of what, when you compute this, you end up with 157, okay, 0.26 ohm. So now we can calculate our what peak supply current, okay, at 50 hertz, okay. So the peak supply current, okay, at 50 hertz, okay, that's our IM is equal to what, we know that the formula is what VM on what Z, okay. So we have our VM, okay. Note that the interrupt, okay, has these parameters already been given, okay, right? So let's just insert our values and then we are good to go. We know that VM, okay, is equal to what 325, okay, 0.26, okay, and then we divide that by what 157.26, okay. So our IM will give us what 2.068, okay, right. This is in what amperes, okay. Let's proceed from there, right? So let's calculate our what final parameter, okay. So our final parameter is what the peak current drawn by the circuit at resonant frequency, okay. Our peak current drawn by what the circuit at resonant frequency, right? So let's proceed from there, okay, right. So we have our C, okay. C is equal to what the resonance at what. So let's just proceed from there, okay. Now we know that at resonance, okay, you know that at resonance our Z, okay, which is equal to R is equal to what 50 ohm, okay. That's at resonance, okay. So we can state that our peak current, okay, our peak current during resonance, okay, our peak current during resonance okay, that's our IM, so you can add O as the what subscript, okay, is equal to what VM on what R, okay. So from here we use what VM on Z because we are using what at the 50 Hz, okay. But this for this one we are using what at resonance, okay, at this point, okay. So we have our what 325.26 divided by what 50, okay, 50 ohm. So this will give us what, when you compute this, you end up with 6.5 let's say 03, okay, 03 amps, okay, right. So this brings us to the end of the first question, okay, right. So this question was a bit, I would say, simpler compared to the second question we are about to solve, okay, right. So in case you didn't understand anything, just leave your questions in the comment section and then I'll reply to them, okay. Or you can go through the solution again so that you get to understand, okay. Now let's move on to the second question, okay. The second question, right. Okay, so we have what, the entire question being summarized in what, this diagram, but we need to maybe read the question, okay, in order to what, understand, okay. So let's do that. Let's try reading the question in order to what, understand, okay. So we have what, two impedances, okay, Z1 as what 0.8 plus what J5.6 ohm, and then we have what Z2 8 minus J 16 ohm, and then what, a single phase motor are connected in parallel, okay. So that's why these are what, connected in parallel. So the first one, the second one, first impedance, second impedance, and then connected to what, a motor, all in what, parallel, okay, across a 200 VRMS, okay, across a 200 VRMS, okay, 60 Hz, right. So supply as shown below, okay. So this is the diagram. So you have two impedances, Z1, Z2, and a single phase motor connected in parallel across a 200 VRMS 60 Hz supply as shown in the diagram below, okay. The motor draws 5 kVA at 0.8 power factor lagging, okay. So that's what we have over here, okay. That's what we have over here, okay, right. Now we have to do what? So the entire question is being summarized into this diagram, okay. So now we have to find the complex powers S1, S2, okay, for the two impedances, okay, for these two impedances, okay. So impedance 1, impedance 2, and then find what, S3 for the motor, okay. So this S3, okay. So we have to find the complex power for the motor, okay, right. And then we have to determine the power taken from the supply, okay, supply currents and the overall what, power factor, okay. And then last but not the least, we have to calculate what, or find a capacitor which is being connected in parallel with the loads, okay. Then we have to find what, the kVA and the capacitance in microfarad to improve the overall power factor to what, utility, okay. So this is what, utility, okay, means what, unit, okay. And then we have what, we have to find the what, the new line current, okay. So let's start from A. Let's start from A. So we have to find what, the, so let's look at our solution, okay. Let's look at our solution. Let's use a visible color, okay. So we have to find the load complex power, okay. So for the load, so this A, okay. So for our load complex power, okay. For our load complex power, we have what, we have to find for S1, S2, and then what, S3 of the motor, okay. So you know that S1, okay, is equal to the magnitude of V squared divided by what, our first Z1, okay, and then S2 will also follow the same format, okay. S2 will follow the same format, Z2, okay. But S3, okay, S3 will be equal to what? A different approach, okay. So when you get to S3, I'll just insert the equation so that we follow the procedure to calculate. So now let's calculate S1. So we have S1 to be equal to what? Magnitude of what? V, okay. So we know V to what? 200, okay. So from our calculation or from the question, we know V to what? 200, okay. Right. So we've already given V, so there's no need to find to calculate the magnitude again. So we have what? 200 squared divided by what? 0.8, okay. So we have minus what? J, okay, 5.6, okay, and then this will give us what? When you compute this, you end up with 1000, okay, 1000 plus J, okay, and then we have what? 7000, okay. This is what? VA, okay. So let's proceed to what? S2, okay. So we have S2 using the same approach. We have 200 squared and then divided by what? 8 plus J 16, okay, and then we'll end up with what? When you compute this, you end up with what? 1000, okay, minus J, okay, you have 2000 VA, okay. The unit for S is what? VA, and then we have what? S3, okay. So let's see how we calculate for S3. So S3 will be equal to what? 5000. So we have what? 5000, okay. That's what? S3. So we have 5 kVA. So we have what? 5000, okay. We have 5000, okay. So K is what? 10 exponent 3, okay. So that's what? 5000, okay. And then we have angle of what? 36.87, okay. Right, so that's from our what? Power factor. So when you compute the cos theta of this, okay, so we know that power factor is equal to what? Cos theta. So we are taking what? The cos inverse, okay, the cos inverse of what? The power factor, okay. Right, that's why we end up with this value. So when you compute this, you also end up with what? 4000, okay, plus J, then we have what? 3000 what? VA, okay. So we've been able to calculate what? The individual S1, S2, and S3. So we can now calculate what? The total, okay, the total complex power, okay, total complex power. So that's where you sum everything up, okay. So we have what? When you sum everything up, that's S total, okay. When you sum the whole of so let's start from here. We have what? 1000 plus J, okay, 7000, and then we have what? Plus 1000, that's S2, okay, minus J 2000, okay, and then we have plus what? 4000, okay, plus J, okay, 3000, okay. So when you do that, you end up with what? X value of what? Let me rewrite that, okay. So we have the total value to what? When you compute all of this, you end up with 6, okay, plus J8, okay, which is also similar to what? In polar form, you have 10 and then an angle of what? 53.13 degrees, okay. Then we have that kVA, okay. Note that K, okay, note that K is equal to what? 10 exponent 3, which is equal to what? 1000, okay. That's why this has been reduced to what? 6 plus J8. Else this would have been what? 6000 plus J8000, okay. Right. That's why we have K over here, okay. Right. So let's proceed. Let's proceed to what? B, okay. Let's proceed to question B. So we have to determine the power taken from the supply, okay, supply current and the overall power factor, okay. Now, so let's see how we go by that. So this is B, okay. So to find that, we need to know that X, okay, is equal to what? VI, okay, is equal to VI, and then in calculating I, okay, calculating I, we have what? S divided by what? V, okay. So how do we do this? We just insert our S value, which has already been calculated over here, okay. So that's what? 10, and then an angle of what? 53.13, which is in what? kVA, okay. And then you divide that by what? Your voltage, okay. That's what? 200 with an angle of 0 degrees, okay. Now, in order to make this simple enough, we could just write this in what? And then omit our kilo, okay. So we can just write what? 10,000, okay. 10,000 with an angle of what? 53.13 degrees, meaning we've been able to remove the K, okay, and then divide that by what? 200 with an angle of what? 0 degrees, okay. So when you compute that, you end up with what? When you compute this, you end up with I value of 50, okay. When you punch this on your calculator, you end up with what? 50 and an angle of what? Minus 53.13 degrees, and this is in what? Amperes, okay. Right. So now let's look at the power factor, okay. So now the power factor, as we all know, which is equal to cos theta, okay, will be now equal to what? Cos 53, okay, 53.13, okay. Note that we were to calculate what? Determine the power taken from the supply, okay. That's what the supply current, okay. So determine the power taken from the supply, that's the same as what? The supply current, and then we also calculate what? The overall power factor. So we just get the angle which was calculated from what? The supply current, and then we take the cos of that angle, okay, and then we end up with what? Our power factor being equal to what? When you punch this on your calculator, you end up with 0.6, okay. So this power factor will be what? Lagging, okay. Note it's positive, so it will be lagging, right. Let's proceed to the last and final question, okay. So we have to calculate what? Okay, so we have what? A capacitor is what? Connected in parallel with the loads, okay. So now from here you also have another capacitor, okay, being connected, okay. So you could notice that we have a capacitor over here, okay. We have a capacitor over here, but the question states that we have what? A capacitor connected in parallel with the loads, okay. So we have to find the kVA and what? The capacitance in what? Microfarad, to improve the overall power factor to unity, okay. So after that we calculate what? The line current. So this is how we go by that, okay. So C, this C, okay, C. So we know that Z, okay, or let's say Z for the capacitance is equal to what? V squared divided by what? S. This is just changing subject, so S for what? The capacitance. So from here you could notice that we use what? S equals what? V squared on Z. So this is just change of subject, okay? We just make Z the subject. That's it, okay? Nothing magical to see over here, okay? So now we already know V to what? 200, okay? And then we square that, and then we divide that by what? SC, okay? SC, which is what? 8,000, okay? Right, so let's check that. Okay, right, so from here we have what? The capacitance which was being connected, okay? Right, so we have 8,000. Okay, so let's proceed. We have 8,000. Okay, now so let's compute that. Let's compute that. So we have what? When you compute this, you end up with what? Minus J5, okay, ohms, okay, right. So this is the what? The capacitance impedance, okay. So this SC, note that, okay, that's SC, very important. And then we have to calculate what? The capacitance with microfarad, okay, right. So okay, so let me rewrite that. So this is what? Our capacitance, what? This is our capacitance impedance, okay? Capacitance impedance, okay? So now we calculate our capacitance, okay? We calculate our capacitance, okay? Right, so we have what? Our capacitance being equal to 10 exponent 6, okay? And then divided by what? 2 pi, okay? 60 multiplied by what? 5, okay? So in case you remember this formula, okay? In case you remember this formula, that's good, okay? In case you don't, you could check out our video on what? Impedance, capacitance, and inductance, okay? That's how you're able to come up with what? The capacitance formula, okay? And then their respective parameters. So when you compute this, you end up with what? 530, okay, 0.5 microfarad, okay? Because the question asks us to what? Calculate the what? The capacitance in what? Microfarad. Hence this formula, okay? Hence this formula, okay? Right. So let's proceed from there, okay? Let's proceed from there. Okay. Now this is our frequency, okay? I'm trying to prove the formula to you, okay? This is our frequency, okay? That's our frequency, okay? So that's the frequency we use in calculating our capacitance, okay? That's the frequency we use in calculating our capacitance. So if you already know the formula for calculating for capacitance, okay? So we have what? SC, okay? SC is equal to what? 1 over what? 2 pi, okay, FC, okay? So you can just derive your capacitance from here, okay? That's how you're able to calculate our what? Capacitance, okay? Now let's see how we go by what? Calculating our what? The new line current, okay? The new line current, okay? Now we know that for new line current, okay, the new line current, okay, so by now you might be contemplating that this question is a bit complicated, okay? So these are some of the questions you'll be meeting in your exams. That's why I've taken time to, handpick these questions so that you get exposed to these kind of questions and then how to go by them, okay? So during your lectures you'll be introduced to the simplest concepts, okay? So once you get to know these questions, you'll be able to solve other complicated questions, okay? S divided by what? V, okay? So from the initial formula. Okay, right, so let's proceed. We have what? S to be what? 6,000 with an angle of what? 0, and then we have what? Our V to what? 200 with an angle of what? 0. So when you compute this, you end up with what? This cancels that, this cancels that. 2 in here 1, 2 in 60 is what? 30. Okay, so we have what? 30 with an angle of what? 0 degrees, and then current should be in what? Amperes. Okay, right, so this brings us to the end of this video. So as I stated earlier, these are the kind of questions you'll be meeting in your end of SEM exams. Once you get your hands on these kind of questions, you get to understand or know how to go about certain difficult questions. Okay, right, so I hope these solutions and these questions were very helpful. Okay, right, so hope these were very helpful. I will urge you to subscribe to the channel. Okay, switch on your bell icon so that you don't miss out on any uploaded video or tutorial questions or videos that might help augment your studies. Like the videos, share to your friends. Okay, and then others who might need this video in their academics, and then I'll see you in the next video.